Hello, and welcome to Astronomy 100. In this video, we're going to continue going through some of the physics that's related to the astronomy course, and in particular, we're describing what is called orbital mechanics. And what we're going to do is steadily work our way to an understanding of what it means for a body to orbit around another body. And so the idea, of course, seems fairly simple. One object is orbiting around another body, but there are components to it that are a little bit more complicated that, taken all together as a package, describes this notion of orbital mechanics. So in this particular video, we're working our way through Newton's laws. In the last video, we talked about Newton's first law. Newton's first law is a body at rest stays at rest unless acted upon by an outside force. A body in motion continues in motion, moving in a straight line at a constant speed unless acted upon by an outside force. In this video, we're going to work our way to Newton's second law, but before we can get to Newton's second law, we have to establish some definitions that are going to be used in the concept itself. So let's go ahead and get started on that. Now, one of the first definitions that we're going to use links Newton's first law and second law together. It's the word inertia. The definition of inertia is an object's natural tendency to resist changes in motion. Now, what this simply means is that an object will continue doing what it's already doing. If you think about it, Newton's first law is essentially the concept of inertia, and it is often referred to as the law of inertia. An object at rest will stay at rest. In other words, it's going to stay doing what it's already doing. An object in motion will stay in motion, and of course that means it is doing what it's already doing. So an object will have a natural tendency to resist any changes in what it is currently doing. Let me give you an example. If you've ever had the privilege of having to push an automobile, or for that matter, anything that's very heavy that is on wheels, what you'll notice is that it takes several people to make the car start to roll. Even if the brakes are off, you have somebody steering the car. This might be an exaggeration in this picture, but it usually takes maybe 2 people, maybe 3, to make the car start to roll. Now, sometimes we think of it as, well, it's just because the car is heavy. Well, what is actually happening is you have to overcome the inertia of the car. The car is a body at rest, and you want to make it a body in motion. So what you are doing is overcoming its natural tendency to resist changes in motion. It is at rest. It is going to stay at rest. You have to change that by making it roll. So it takes a great deal of effort to push it to get it to start to roll. But what you'll notice is once the car is rolling, it really only takes one person to keep the car going, because in this case, it's an object in motion that continues in motion in a straight line at a constant speed. And so all you're doing by constantly pushing it is you are simply overcoming the air resistance and the friction. The car itself is trying to stay going, stay moving, because that is the inertia. If it's an object in motion, its inertia is it's going to stay that way, and so therefore it will roll almost all on its own. You just have to keep it moving to overcome friction and air resistance. So once you want to stop the car, then of course it usually takes a couple of people to run around to the front of the car and then put in a great deal of effort to make it stop, because it's an object in motion. Now you want to change that. You want to stop it, so you have to overcome its inertia. So inertia can be a body at rest. Inertia could also be a body in motion. And it is the natural tendency for an object to resist any changes in what it's doing. The next definition is the word mass. Mass is one of the most misunderstood concepts in all of science. Many people who are sort of new to science really get this mixed up with a couple of other ideas, and I hope to fix that here today. The definition of mass is a measure of the amount of material that makes up an object. Now notice how very simplistic that is. It's a measure of how much stuff that something is made out of. So when you measure the mass of something, you're really measuring the quantity of the material that the object is made out of. I have a couple of examples here today that I'll show you. For instance, this is a steel block, and it is made entirely of steel, lots and lots of atoms, and so it has a mass. The mass of this steel block is the quantity of atoms, the material, the quantity of material that this object is made out of. If I want to double the mass of this block, I would need to have twice as much material. If I want to make the mass of this block go down by half, I would have to cut it in half and physically take away half of the material. So an object's mass is the quantity of material that the object is made out of. The problem, though, is many people mistake the idea of mass with the idea of volume and of density. So let me show you the difference. This is a styrofoam ball. Now, a styrofoam ball is mostly air. It is what's called polystyrene. It's essentially plastic, but it's been puffed up with tremendous amount of air. So there's lots of air pockets inside of this. Notice the size difference. This styrofoam ball is much physically bigger in size, but this steel block is more massive. I can actually prove that to you. If you'll notice, when I go down, you can actually hear that it has some heft to it, whereas the styrofoam ball really does not. So you can have an object with a great volume, bigger volume, but not as many atoms. So there are not many atoms, but yet those atoms are far apart, making it a big volume. Here is a block of lots of atoms, but they're very, very close together. So volume is the space that something takes up, bigger volume, smaller volume. Density is how much material is in that volume. So low density, high density, because you have a lot of atoms in a small volume. You have atoms that are very close together, you have a high density. Atoms that are far apart, you have a low density. So the mass of something is simply the quantity of material that it's made out of. And then, of course, what we have is the idea of density and volume. So mass is the number of atoms that make up an object. And then density is how tightly they're packed together, or how loosely those atoms are packed together. And then volume is the space that something takes up. So make sure that you keep these three concepts separate. Mass is really not related fundamentally to anything other than the quantity of atoms that make up an object. Now, this brings us to what mass is often confused with, and that's the idea of weight. Weight is defined as a measure of the gravitational force between two bodies. And so weight is actually a force. So weight is a force. It's the force of attraction, or the gravitational force between two bodies. And let me show you a couple of examples. For instance, if I were to be this person in this picture holding this tennis ball, before I drop the tennis ball, of course, I would notice that the tennis ball is being pulled to the ground. That is the weight that you feel when you hold something in your hand. The weight of the tennis ball is the force of the earth pulling on the tennis ball, and the tennis ball also pulling on the earth. And so you'll notice that when he drops the tennis ball, and this is a great picture, they used a strobe light and a multiple exposure in one single frame using a strobe light, you can see the tennis ball fall. Now we all know the tennis ball hits the ground, but if the ground weren't there, if the ground didn't stop the tennis ball, it would have kept going. Where is the tennis ball actually trying to get to? Well, it's traveling to the center of the earth. So the earth is constantly trying to make objects come to its center. And when you feel the weight of an object, you are actually feeling the earth's gravity pulling on that object, trying to make it come to the center of the earth. And so you feel the force by calling it. The weight is simply establishing the concept of that force. Now, When you say that I'm going to lift weights, the problem is that in our everyday language, we say things that are confusing, that are not fundamentally accurate. So an example is, you are not actually lifting weights when you go to the gym. What you are actually doing is lifting mass. And these weights have mass, these objects have mass, and the reason why they feel heavy, hence their weight, is because these objects are being pulled to the center of the Earth, and you are fighting that. By lifting it up, you are keeping the Earth from making that object go to its center. You're feeling the force that the Earth is exerting on that object. What if we wanted to attach a number to the concept of weight? So this is one of the first times in the semester we're going to actually see mathematics and formulas. This is the equation that calculates the weight of an object. W stands for the weight of the object, M is the mass of the object, and G is the gravitational acceleration that is acting on the object. And later in this section, we will talk more about gravitational acceleration. We won't get to it in this video, but we're going to come back to that concept as we go through this section deeper. For now, let's just call it gravity. Now, here's what I want you to notice. If you're familiar with mathematics, you'll know that there's a blank spot between the M and the G, which means there's a multiplication that's happening there. So M times G. Now, let's say we wanted to make an object have no weight. We wanted an object to have 0 weight, to be weightless. To make W 0, we have two options. We could either make the M 0, because 0 times anything is 0, or we could make the G 0. Now, if we make the M 0, that's kind of meaningless, because if the mass is 0, means you have no atoms, which means you have no object. So obviously, if there's no object, it will not have a weight. So what if we couldn't make the M 0, but instead we make the G 0? If you make G 0, then of course 0 times anything is 0. Now notice, what that means is taking away gravity, taking away the force that's acting on the body. And so if the G becomes 0, notice that the weight is 0, but it still has mass. So what that means is an object can have mass, but no weight if you take away gravity. So weight is not the same thing as mass. Weight is the force acting on mass. So make sure you see the fundamental difference between the mass of an object and the weight of the object. The mass is the quantity of material. The weight is the force that the Earth is pulling on that quantity of material. Now, this picture you see here on the right, when you step on a scale, what is actually happening is the Earth is pulling on you, and the Earth is trying to take you to its center. Now, clearly the ground gets in the way. The ground prevents you from going any further towards the center of the Earth. If you slide a scale between you and the ground, notice that you're now on the scale, which is on the ground. What's going to happen is the Earth is still pulling on you, but there's a big spring inside of this machine that when you feel the Earth pulling on you, when it pulls you towards its center, it forces the spring to compress. And when the spring compresses, through a series of gears and sprockets, it will cause the dial to turn. So what the dial is actually telling you is the amount of force that the Earth is pulling on you. We simply call that the weight. So when you weigh yourself in the morning, what you are actually doing is you are measuring the force of attraction or the force of gravity acting between you and the Earth itself. So you are actually measuring a force rather than anything other than that. Now, of course, in our language, we get very confusing with this. You are probably familiar with many, many different diets that will tell you you will lose weight. In reality, the diet isn't for you to lose weight, it is for you to lose mass. It would be confusing if we called it the Jenny Craig mass loss diet, or if you were to likewise say, I'm going to go to the gym and lift a bunch of mass. In reality, that's what's happening, but we tend to just make the word into something it's not. So remember, by losing mass, you will weigh less, because less mass means less weight. So there are some fundamental differences between the concepts that we've defined here, and these definitions are going to be critical when it comes to defining Newton's second law, and of course they're very critical when it comes to the concept of orbiting bodies. In the next video, we will now be ready to define Newton's second law, and we will go from there. I hope you'll join me.